what to say, but something's getting in the way. This person that you so admired, now stuck in such a bad attire. On the road.
Oh my God, you more money. Oh my God, you more money.
Will I cry? Will I leave behind broken and crumbled signs, hiding all my roads to you? Uh-oh. And if I fight, will I come to life, calling for all your light, giving all my heart to you? Uh-oh. And I've been falling, I've been lost, and I've been calling on my ghost. I put it to rest because I'm coming home, coming home. Oh. I am done. I will stay to find every hidden sign, taking all my roads to you. Uh-oh. And I will fight. I will come to life, calling for all your lights, giving my light back to you. Uh-oh. Don't stop, turn off the lights. Nauseous when I wake up. Don't quit, I fell for you. Don't break it in two. Long time before I knew us two would follow through. Hold out, don't give it up. Good things can come to those who wait. 'Cause you make me feel like this is for real. And I want you till trees grow on the moon. If you're a falling star, I wanna fall with you. I want you till it falls out the sun. It's standing up for you. It's standing up for you. Ooh. Standing up for you. Standing up. Standing up for you. Break down when we're apart. Too far, I'm in the dark. Now don't fold my foolish heart. And don't wait for magic sparks. Make it work, although we get stuck on the low. Breathe out, we can't forget. Hurts like a bayonet. 'Cause you make me feel we're in this for real. And I want you till trees grow on the moon. If you're a falling star, I wanna fall with you. I want you till it falls out the sun. It's standing up for you. It's standing up for you. Ooh. Standing up. Standing up for you. Ooh. Standing up. Standing up for you. And all I need is reassurance. All for you. Long time. All for you. I want you till trees grow on the moon. If you're a falling star, I wanna fall with you. I want you till it falls out the sun. Standing up for you. Standing up for you. Standing up. Standing up. Standing up for you. Standing up. Standing up for you.
I hear thunder, I hear lightning, I hear wonders, and everybody wanna go, but no one really cares to know. I see marvels, I see titans, and some troubles that everybody has to face, that no one really can erase, and they hide away from it.
Hello, everybody. Welcome to the Microsoft Reactor. This is a space for the Academy team. That's actually a team of 4 of us right now on the ground in San Francisco. Myself, head of marketing, Dan, who's our head of technical design, Nick, head of engineering, and Jane Fang, who's not quite in the room right now, but she's actually the director of the actual overall Academy. Have many of you been here before? Few of you. Okay, great. So I didn't prepare a presentation because I didn't want you to repeat presentations. And it's also not the point of me talking today because you want to hear about HoloLens 2 and the MR services. But I just wanted to welcome you all, and just a little bit about the Reactor if you're new. We have the Academy team, we do meetups, we host hackathons, summits, location-based entertainment kind of summits, things like that. And we do a lot of great stuff here. And if you ever have, in the XR space, want to host something here, then go to Microsoft Reactor external calendar. You can book a space and come in and bring in your developers and work with them. And Jane has just arrived, taking pictures, and that's our director of the Academy. She does everything from BD, marketing, everything, basically. So I'm not going to take up any more of our time. I think it's really important that we get to the meat of this meetup. So without further ado, I'd like to introduce you to, did I say something wrong there? I'd like to introduce you to Dan and Nick with all the juicy details.
Hello, hello. Can you guys hear me all right? Yeah. Cool. All right, so welcome. I'm going to kick off today with just kind of like a brief recap of some of the stuff that we did with our announce, as well as maybe a few additional details. And so I'll do this presentation. Dan will later follow up with a design-centric presentation, and then we'll do some Q&A afterwards. So hold your questions until the end, if you would. That'd be really cool. All right, so I'm going to start off with a video. I don't know if you guys have seen this one already, but it's pretty cool. It does have audio, I promise. Just not today. So that is our new device. We've been waiting a long time to talk about this. We are very excited about this. So this is something that we kind of think about as the third wave of computing. So a little bit about myself first, just so you know I'm not saying anything. I'm a game dev. I'm from a game dev background. I've been working at the Microsoft for 9 months now. I work on the Mixed Reality Toolkit, which, have you guys heard of the Mixed Reality Toolkit? Yeah, it's a collection of wonderful stuff. My personal contribution is lighting tools, the mixed reality lighting tools, which is all about lighting within the context of an additive display or a mixed reality device. So I've been working with the HoloLens for a little while now. I've had a chance to work on some of the demos that you saw from the videos at the announcement, as well as some other things too. So we'll go back to the third wave of computing. So we'll talk about third wave of computing. We'll talk about some of the things that we have available for you, some of the stuff that we've announced, some of the services that we've created, some of the technologies that we have available. The third wave of computing is about the HoloLens, but it's more than just the HoloLens. It's about creating a connected world, about kind of breaking the boundaries of the digital. This is, I'm really getting things out of order today. So the first wave of computing, it was desktop computers. This is a long time ago. We started with computers. That was kind of revolutionary. It was a really big thing. Later came smartphones. Smartphones was also pretty enormous. Like, all of these things were really transformative. They changed the way that we interacted with the world, with information. It was really just kind of magical. So we had these smartphones that just came in our pockets. We can take them out. We can look at the world. We can get information about that. But now we have this third wave of computing. This third wave of computing takes all of this stuff that was just like in our hands, on our desks, and takes it into the real world. Right? So we no longer have to sit there and like go find our computers in order to get access to information. We can just see information all around us. It's just overlaid onto life itself. We have these AR displays. We have these personal assistants. We have sensors that sit in the corners of your room and tell you information about what's going on here and there and elsewhere. So, like, mixed reality is kind of what we call this. It's this mixing of the digital world onto the real world. And this is something that we've kind of stuck with. Like, a lot of people say XR or VR or AR. Our vision of what this is mixed reality. We consider mixed reality to be this third wave of computing. And so mixed reality is kind of a little bit of everything. It's the spectrum between digital and physical, which makes it a really helpful kind of category, like, because you can fit a whole lot of different stuff in here. This doesn't just encompass virtual reality and augmented reality. It also encompasses everything in between these. So this, like, your smartphone falls into this category. Weird things like the looking glass kind of count. It's a catch-all for the spectrum between augmented and virtual. So we also kind of look at this, because this is the next generation of computing, this is a really big deal. And not just in the way that we interact with things, but also from like an opportunity perspective as well. So this is kind of our estimate for the next 5 to 6 years. We're looking at this as possibly a $144 billion industry. This is a big deal. This is on par with both of those previous waves, except the difference in this particular case is that we expect this to happen significantly faster than it did with phones and computers. So you may have noticed from our marketing that we have a very enterprise focus for this device. We do kind of consider it a little too early for consumers. This is an enterprise-focused device. So the bottom of this scale is kind of where you're going to see our focus initially. It's enterprise, businesses, getting stuff done in commercial environments. We've placed a lot of emphasis on that. Our devices are built with industry in mind. We have all these certifications and stuff that make sure that they can go in work environments and situations like that. I'm personally very excited about productivity and collaboration opportunities. I really am most excited about mixed reality as a productivity opportunity where I can take my hands and interact with tools just in real life and not work at a desk. That's kind of a big thing for me. And then, of course, there's the consumer market, which we'll get to eventually. Sooner rather than later, 5 to 6 years, that's probably around when. So you kind of want to be involved in thinking about this stuff now rather than later, because this is going to happen, and it's going to happen fast. Mixed reality really changes a lot of different things. So I think one of the most obvious things that you can point to is training. This is something, I had a magical experience when I went down to Boost VC last year. There was, I believe this was Tribe XR. They had a DJ school experience. I don't know, has anybody here seen that? A few of you. So this was my first training experience in, this was VR in this particular case, but they sat me down in front of a DJ set and they went through these instructions. They taught me how to work with this thing, and then like, it was kind of cool. It was fun, like flipping all the switches and dials, but then they took me out of it. And right there in front of me was the same exact DJ board. And as soon as I looked at that, I was like, this is really cool. I know exactly what to do with this. And so I started, squeegeeing the wiggles and whatever. So that was pretty amazing. The other interesting thing that I saw was a a collaboration and communications tool for meetings, remote meetings. And like, I know these are kind of like, oh man, this is so enterprisey, but it was actually really cool. Like this was the example that they had in this particular case was a team that would meet, I don't know, almost 50 times a year. They lived in different countries in Europe, and they would all fly to one spot every couple of weeks and have a meeting and collaborate on design and experiences like that. And they started using this collaboration software that would allow them to meet in VR and talk with each other, interact with each other, do these presentations and share notes and everything. And it was transformative for their team. They met only once a year after that, but they increased the amount of virtual meetings that they had, and they were just blown away by what they could do with that. Now imagine if that was with an AR device and they could actually interact with everybody around them while they were doing this, in addition to the people that were remote. So these are some of the things that you can think about how a mixed reality tool set is going to change the world that we work in. Everybody's kind of moving to this remote work anyhow, and so this is going to be very fundamental. So here's another thing. When we released the HoloLens 1, we have like about 3 years worth of learnings from the HoloLens 1. We saw a whole lot of people do a lot of interesting things. But when it came to enterprise, we saw a couple of common items that just came up over and over again, like what are people doing with this device? So these are kind of the core ones that we identified as far as like what's low-hanging fruit. What can we grab and do and provide to other people so that when they have a HoloLens, they can just get started with this immediately. And so we have a couple of tools. This is our Microsoft Dynamics 365 business applications. These aren't like, you know, super fantastic gamey things, but these are going to get work done, make you productive, and solve real problems. So the first one is Remote Assist and Layout. These are ones that we announced a little while back, and you've probably heard of them. Some of the newer ones that you haven't seen much of are Guides and Product Visualize. I believe Product Visualize has more information coming out later in April. But Guides is really interesting, and I'm going to show you a video of that one right now, just because it's kind of cool.
Work today is more complicated than ever. The old ways of training cannot get new employees up to speed as fast as the experienced people are retiring. We need a better way forward. Introducing Dynamics 365 Guides. Simple step-by-step instructions are easily written on a PC, and then holographic parts and icons are simply picked up and placed on the machine where the work is happening. From day one, employees are often expected to get work done, but the complexity can be overwhelming. Now, employees can learn by doing. This is a tool that works with existing processes, allowing a manager to get the right guides to their people. The instructions move with the employees, pointing them to the tools and parts they need, showing them exactly where they need to apply them. Employees get up to speed faster, with fewer errors and more confidence. A simple glance moves them through the instructions, meaning their hands are free to do the work. They can learn at their own pace without having to rely on other workers around them. The overall experience is comfortable and intuitive. For the first time, a manager can see detailed information about how the employees are working and how their skills are growing. This makes continuous improvement faster than ever before. All of this helps employees make the complex simple, so they can learn and adapt faster, and organizations can stay competitive.
So that's pretty cool, right? Having that right out of the box is kind of handy. It's nice to have it this time around. So when you get a HoloLens 2, you'll be able to do real things. So here I'm going to go into a little bit of some of the more details about the device. I've got some kind of little video snippets here. At least eventually I do. So this is what I'll talk about in this section. This is kind of our whole mixed reality tech stack. We've got the cognitive services. These are our Azure things that you've probably heard of or seen of. There's like vision technologies, there's speech to text, text to speech, there's language, that's like translation features. We have a whole pile of different things in our cognitive service. But we also now have the mixed reality services, and these are services that are specific to mixed reality tasks. So this is things like Azure Spatial Anchors. This is a big important one that lets you synchronize your location between multiple different devices in a cross-platform manner. That's pretty awesome, and it works really well. We've also got Azure Remote Rendering. So a lot of these AR devices are pretty awesome, but they're also limited as far as power and battery life and stuff like that goes. So offloading some of your render capacity to the cloud can open a whole range of new things. And then we've also got Azure Digital Twins, which is kind of an IoT thing I might talk about a little bit more later. And then, of course, we have a whole set of new devices. So I'll start with the devices, the HoloLens 2. So over the 3 years, as far as the physical aspects of this device are concerned, we had a lot of feedback. I would be a very rich person if I could get a penny every time somebody complained about the field of view. I know it's small, but it is now much bigger. Immersion is something that we really focused on for this device, and it is a lot better. If you ever get a chance to try it on, which hopefully we will have them later on and you will be able to try this out, you will see that it is significantly more immersive. This is also a much more comfortable device. Talking to Alex Kipman, he's very proud of this idea that it's a 3 times more comfortable device. And it's kind of an odd idea to think of something being like a metric for comfortability, but we actually did studies and talked to people and came up with a real number for 3. That's kind of cool. And then, of course, the time to value stuff, and that's the Dynamics 365 applications that you saw. So here's the field of view thing. So this is much bigger, much, much bigger. And the key thing here is that we maintained the pixel density for this. So like one of the great things about the HoloLens is that text is really crisp. You can read things, you can do real text-related tasks, and you will still be able to do that even with this increased field of view. So this is pretty magical. Now, like you'll see numbers, you'll hear all sorts of ratios and whatever. What I will tell you is that the field of view on this is just magical. I was honestly surprised when I heard the number because it felt small. When you actually try this on, it's a completely different story. The display. So this is kind of like some custom tech. I don't know too much about this because this is hardware stuff that I'm not super familiar with, but it's laser-based, and I think we only have 2 waveguides this time instead of 3, so there should be maybe less shimmer. Not exactly sure about that. I'll get back to you on that later. Fully articulated hand tracking. This is the one I'm kind of proud of because I think a lot of people were saying, oh yeah, they're never gonna have it. But we have it, and it's awesome. It is amazing to be interacting with these holograms with your hands. Having this increased field of view and then actually being able to use your hands to touch things is just an incredible experience, and I can't wait for you guys to try this out. Let's see, spatial mapping. So we've got, this is kind of overlapping with the next one, but we have the new Kinect device. I don't know if you've seen much about that, but the new Kinect is a lot better than the old Kinect. It's 1024 by 1024 for the depth information. It's much more accurate. It's got some really nice like far throw and wide field of view detection, so you can switch between them, whether it's doing hand tracking or if it's trying to look at the room. So the spatial mapping stuff is killer, as it always has been. And yeah, the Kinect. Look at that thing. Isn't it beautiful? I'm working on some of the Kinect docs myself, so it's been a blast to work with the Kinect just as a standalone device. But to have this inside of a mobile headset is pretty amazing, too. So we also have eye tracking as well. So the eye tracking, it'll tell you exactly where your eyes are looking. But along with that, as long as we've got cameras pointed at your eyes, we're using this for Windows Hello as well. So when you put this device on, it'll know who you are, and it'll sign you in automatically. That's pretty cool, too, so no more typing in your passwords. Typing in your passwords will be easier, but now you won't even have to do that. Isn't that nice? Let's see, what else? Oh yes, so the fit of this device. This goes back to the comfort. So we actually took a whole pile of people, all sorts of different people, scanned their heads, and built something that would work for all of them. I believe what we say is that 95% of the people over the age of 14 will be very, very comfortable with this device on their heads. That's pretty cool. So we actually spent a lot of time researching this and trying to get this right, and it's a nice headset. So it's also now just a single dial in the back, no more complicated gyroscope hoops and levers and stuff like that. This is just a little clicky thing that you scoop up to the back of your head, and it just kind of sits on like a little hat. It's pretty comfortable. I've done a bunch of development with this on my head, and it's pretty fun to just be able to take it on and off like a regular hat instead of the weird dance you have to do with the other one. And flip-up visor. After seeing this on a VR headset, this was kind of like a no-brainer, but we actually stuck it on the HoloLens 2 now as well, so that's pretty cool. And I mentioned this briefly before. This is built with industrial environments in mind, commercial environments. So it's certified. I don't know exactly what all of these certifications are, but you should be able to use this in a lot of different places where your customers will really appreciate these certifications. I think my favorite part about this, however, is the microphone array that we've got. So this microphone array will be able to figure out what you're saying even at 90 decibels of ambient noise. That is, I think they compare this to having a blender going at full speed right next to you. This is really loud, and it can still understand what you're saying. So this is a significant improvement from devices in the past where you have to like, maybe I can't rely on the audio in a conference setting or in a demo setting. This device will hear you. Combine that with some of our speech recognition technologies, and you have probably the best voice recognition device on the planet. This is pretty cool. Along with this, we've also kind of got some customization programs going on. I don't know too much about this, but this is kind of cool. Stick it on a hard hat, do weird things with it. I want one with the traffic cone top. All right, and then those applications. This thing works right out of the box. You can do stuff right away. Cool. So here's some numbers for you, because I love numbers. We have, so the aspect ratio of these displays, the eyes, are a 3:2. So the last one was 16:9. And so the interesting thing there, 16:9 is very wide and kind of narrow vertically. But that doesn't really make sense as humans, right? So now we've switched it to 3:2, and this is significantly better for actually like interacting with your environment. This is part of why the device feels more immersive, but also because it's better. We've got hand tracking, eye tracking, 5 channels of microphone, cool. A USB-C, a whole bunch of Wi-Fi and Bluetooth, a Snapdragon 850. Hopefully some of these things mean a little bit more to you than they do to me. But yeah. The other thing is the Kinect. Like I mentioned before, I'm very excited about this device. It's pretty awesome. So I've got another video for you. Check it out. When I got the dev kit and I saw those sync ports, I was like, oh yes, I know this is going to be a winner. So this thing is useful in kind of a lot of different cases. Sometimes you look at these devices and go, where do I use this? But this thing, because it has so much data coming into it, it's got a color camera, it's got a depth camera, it's got a microphone array, it's got an IMU. Like, you can take all of that information and do all sorts of things. Stick it on a robot, you got a robot that can see. Stick it on a wall, it's a wall that knows everything that's happening in front of it. You can hook this up to, I don't know, your HoloLens, the Internet of Things, maybe your cloud, and it'll do magic. Here's some of the examples that we've kind of thought of. I think some of these are actually stuff that's kind of being productized right now by certain people. Like the fall prevention one in healthcare. I think we actually had some videos of that where they had a prototype of that will go in. So this is a pretty nice device. You can use it for more than just art. It's fantastic. Let's see. Here are the specs on this. When I saw that the camera had like 4,000 by 3,000 pixels coming in on it, I was like, what on earth am I going to do with all this data? But I'm sure some of you guys will think of something to do with it. It's pretty good. Yeah, so take a picture of that if you want. But so that's the devices. So now we've got some services to talk about. I think we're just going to do the bottom three here, because the rest of them are kind of been around for a little while. So Azure Spatial Anchors. The idea with this one is you can kind of sit there and like take your phone, take your HoloLens, maybe it's an Android, maybe it's an iOS device, maybe it's something else. It's a cross-platform API. You can scan your room and it'll go like, I know where I am, and you can hook a couple of these devices up to this anchor and they'll all know where they are in relation to each other. And the nice thing about that is like you don't need your QR codes, you don't need a poster. All you need is a color camera. You don't even need a fancy Kinect that we've got, just a color camera. And so in addition to that being cross-platform, you can use this on so many different devices just to start talking to each other and interacting with each other in a digital manner. Simplifies a whole lot of things. So this is a good one to check out if you've ever done any collaborative AR stuff or MR stuff. Remote rendering. So this is one I managed to get a demo of because I couldn't believe it. Like, the idea that you can stream video to your HoloLens and have it not make you sick or anything like that is kind of absurd to me. But then I got to actually try it. Like, they were rendering on a server. I don't think it was even in the same state. But because of the prediction algorithms that they use, this thing actually keeps up with you super well. You can render millions of polygons using remote rendering and display this on a HoloLens. So this is pretty fantastic. You don't have to worry about that decimation workflow anymore if you don't want to. You just hook this thing up into it and go. So that's pretty amazing. There's also this digital twins thing, too. I don't know too much about it, but I believe the idea is that you kind of have a digital representation of a physical environment, and it lets you see some of the sensors that are inside of that. Like, if you have a Kinect hooked up to your wall, this is where you would actually get that information from the Kinect. You can view it as a digital twin of that environment. Kind of a cool thought. And then cognitive services, a whole bunch of stuff. If you haven't looked at them, they're fun. So, with all that stuff, where do you go to get started on this? That's a whole pile. So, one of the things that I'm really excited about this, we got Tim Sweeney on stage to say it in everything. We're an open platform. We like to be open, okay? We just brought in support for Unreal. You can still use Unity. There's Sharp if you want to use C#. Like, we're big on opening this up to everybody and getting you on this platform. We don't really care what you're using. We really just want you to use it. So pick your poison, go make with that. But in the meantime, we have a pretty big investment in the Mixed Reality Toolkit. This has been our go-to toolkit for a long while. If you build for the Mixed Reality Toolkit, then your application will work on the HoloLens 2 pretty much right away. So if you're interested in getting started for this now, I would say double down on the Mixed Reality Toolkit, give it a go, learn the vNext version. I believe we have some betas out for that now that are pretty well along. Things are getting integrated into it that used to be really private, so you might see some fun things in there. And so this is kind of the workflow. Like, if you're going to actually take something and put it on there, like upgrade your project to 2018.3. This is kind of one of the more recent versions. It's a big change from a lot of the other Unity stuff, the nested prefabs and all that. It's a good version. It's actually pretty solid. They did a good job with this one this time. So happy to say, upgrade to 2018.3. That's kind of our current target for the MRTK. Upgrade to your MRTK version. So if you're using the old one is definitely not the same as the new one. You might have some trouble getting that going. We'll have some guides in place at some point or another. There may even be some up there right now. But switch to the new MRTK. Make sure that your application runs on ARM. So the new device is, of course, a Snapdragon 850, which is an ARM chip. So make sure that you can compile everything to ARM. This is going to be like if you have DLLs that you use that are native, go compile them to ARM or make sure you can find an ARM equivalent. And then later, once you have access to a HoloLens, you can do the HoloLens 2 interaction stuff. You might even be able to get away with approximates, like sticking a magic leap to a VR or leap motion. Sticking a leap motion to a VR headset and wiggling your fingers around. That would be a pretty good place to start. Maybe you can get a Tobii eye tracker for playing with eyes. There's a couple of options right now, but you can always just wait for the real thing, too. Here's a good link. This link is actually pretty fantastic. So it's also known as .microsoft/mixedreality, or if you want to shorten it, aka.ms/mr. But that one has like pre-order things, it has documentation, it has sign up for our newsletters, it's got links to everything else that's super relevant. So go to that one. That's the most important one to remember. This next slide I've got is just kind of a mishmash of all sorts of links to everything and anything that I just showed you, as well as a few others. But this is the most important one if you actually want to get things done. So here's the last one. It's quite a few, I did say. All right, so that's all that I've got for you. I'm not going to take questions quite yet. We're going to have Dan go, and then afterwards, we're going to take questions later. Sound good? Thanks, guys.
Okay, hi everyone. My name is Dan Escudero. I'm the mixed reality developer ecosystem design lead. I'm going to tell you a little bit about myself. I've been around in interaction design for like over 15 years. Started coding with Flash and then moved into Unity development. And I've been 3 years at Microsoft, dedicated to HoloLens. The first 2 years were in London, working on app prototypes for customers, specifically for HoloLens. And during the last year, working here at the developer ecosystem, doing talks like these and working on MRTK tools and documentation. I also led Spectator View for mobile, which is in MRTK currently. And I'm currently working on the playground. Some of you might have heard of the playground in the keynote, and we're going to talk about that in a few minutes. So I'm really, really excited and a bit nervous to be talking about HoloLens 2, like after so many months and actually years waiting for this to be public. I remember people asking what can you tell me about HoloLens 2, or will it have this, what about the field of view, and blah, 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 blah. And now at last we can talk about 70% of what is public. So yeah, I'm super excited, and hopefully we can answer lots of questions later. So Nick went through tons of different features, but I'm going to focus on something slightly different. I'm going to focus on 4 specific features that combined actually change the way how we interact with computers from now onwards. Okay? So I want to start with the first one, articulated hand tracking. So Nick already read through a few of the details, but to go in deeper, what we are tracking is 25 joints per hand, and that's a lot of joints. Think of that, plus all the sensors scanning the room, microphones listening to you, and all the display, double display. It's a ton of stuff going on right here. Remember, it's an untethered device. So not only are we recognizing your hands, we're actually tracking them in the space around you, so we know where they are in space. And that allows us to do like super magical things like the hummingbird that you saw right there. I'm going to play this video again, I love it. Reach out your hands. That's one of the like first key moments when you wear a HoloLens too. And then the hummingbird experience, which we call the magical moment, which you'll probably experience at some point during the next month. Hopefully here, where we can show it to you. The second one is field of view, of course. Now, field of view on HoloLens 2 has actually doubled the size, the size area, and that's pretty big. That's a game changer, actually. And this was like #1 feedback that any customer, any developer would say like, what's up with the field of view? Why is it so bad? It feels broken. But now it's not. It's so different. It changes the way how you perceive holograms. They don't feel like they're on a screen far away from you. They are actually here, right in front of you. I can grab them. So the main thing about the field of view is that it allows you to show a lot more content, right? It's a lot more immersive, obviously, because basically wherever you look, there is a hologram. But also as a developer, it gives you a lot more freedom. Before, you're actually restricted to, imagine the field of view is like this, the old field of view is more or less like this. So you were restricted to either putting holograms within that field of view, or as a user, stepping back to get them inside your field of view. And that's a really crappy experience if you think of it. And also like air tapping, because you are far away from them. So now, holograms can be really, really close. So I'm not sure how many of you have ever played with the clipping plane in MRTK or in Unity. And for HoloLens, we recommend it to be, for HoloLens Generation 1, we recommend like 0.8 meters away from you. And I would bump that up to like 0.1, just because it's big. And I want to see holograms closer. But now, we want them really close to you. We want them at hand distance. So now it's an invitation to interact with holograms and not just being like a far away observer. Sorry? The recommended near plane? I think it's like 0.2. It could be less. It depends on your use case. I always say like near clipping plane depends on what you want to do and for how long. How long is your measurement, I think. Third one is, of course, eye tracking. Eye tracking is quite of a big deal. But it's a lot trickier than you think. Like everyone thought like, oh, Magic Leap has eye tracking. Did you see anything with eye tracking on Magic Leap? Yeah? Right. So it's not a user thing. It's a technical thing behind the scenes, in a way. And that's the deal with it. Like, it's not easy to play around with eye tracking. And I'll tell you why. In a while, not now. So basically, as a developer, you now have access to where a user is eye gazing. And you know where their eye is spotted in depth, of course. So now you can start gathering information about user intent, which is probably what you want to do all the time. So Nick already talked about Windows Hello and IPD adjustment and what this brings to demos, especially to demos. Like when you pass around a HoloLens to someone else, you don't have to do like weird measurements or bring out that IPD measurement machine. Just pass it on to someone else. And if they're already signed in to Windows Hello, it just adjusts and it just works. So the main things about eye tracking is the eye muscle actually is the fastest moving muscle in the human body. So it's super fast to like point at stuff. I wouldn't say point, just look at stuff. It's really, really fast and it's effortless. And another thing is implicitness. There's one cool demo that if any of you, did anyone go to MWC where the HoloLens 2 was announced? There was one demo, there were two demos actually that used eye tracking for automatic scrolling. So you had a simple 2D canvas in front of you with some text and you could read, and as you read down, it automatically starts scrolling up. And that is mind-blowing. It sounds so simple, but it's mind-blowing. Because it's reading your mind, it's literally reading your mind. So you can use eye tracking to your advantage. Also, it's an extremely powerful form of input combined with other forms of input. So, for example, if I'm looking at something, I want to make sure I can air tap still, or I can click, or I can do a voice command while looking at something. Because you don't want to trigger things just by looking at things, right? But everything will start popping around. That's going to be very uncomfortable. You want to make sure that it's a form of input that actually works with other forms together. And of course, you can track someone's intention. So think of a multi-user experience, but with remote users. So I'm here working on something on my table here, seeing some, let's say, a command center hologram, and I'm moving things, and I'm working with my coworker who's in Paris, and he's also experiencing the same application, and I can see his avatar. I might be able to see his eyes now, actually, to see where they're looking, or, probably less creepy, I could actually see where he is looking at on the hologram. And the fourth one is semantic labeling. Has anyone heard of this? Cool, not too many people. So when the HoloLens 2 scans your environment, it can actually pick up immediately lots of common objects. And to name most of them, you've got tables, chairs, sofas, screens, walls, floor, ceiling, and doors, and more to come in the future. Now, all these interactions combined create what we call instinctual interactions. And I know some of you, or most of you, saw the keynote of the announcement of HoloLens 2, but I want to show you my favorite part, the playground demo.
Welcome to the playground. We spent years exploring and refining interactions for HoloLens 2. And the playground is just a tiny sampling of the many prototypes that we built, tested, and learned from. Our approach is basically to try out as many things as we could and look for the things that stood out. So, for example, here I've got 3 sliders. Each of them is controlling this wind farm simulation, but each in a different way, using a different interaction technique. One of the things we tried is this touch slider here. So here I can just stick my finger in the slider and have it go to a particular value to control that wind speed there. It felt okay. We also tried this push slider. So this guy can kind of nudge from side to side, kind of like an abacus, which was interesting. Now, the interaction that really took home the cake, though, was this pinch slider. The way that works is you just pinch it and move it wherever you want. How do you press buttons on HoloLens 2? Well, you just reach out and press them. Now, one interesting thing that we found about buttons was that the size of the buttons actually impacted the way that people interacted with them. So, for example, for the smaller one, most people would use 1 or maybe 2 fingers, but for the larger one, pretty much everyone used their entire hand. And this is kind of interesting when you think about it, because these objects don't really weigh anything. They're just digital things. But despite that, people would treat them like real things, almost as if the bigger one had more weight. All right, how about something that uses all 10 fingers? Well, to test that out, we built a piano. So here I can just play a chord, or I can play the keys one at a time. I wonder if it will fly to my hand. Yeah. Oh, wow. This is beautiful. I just love the way that it's following my hand around. I've got to tell the team, they've done a great job. And in fact, I don't even need to use my hands to do this, because I can use my eyes and my voice. That's right. HoloLens 2 has eye tracking. So I can just look over to this browser here and look at the bottom of the screen to scroll it, and then send my message. Start dictation. The hummingbird looks great! Exclamation mark. Send.
Isn't that amazing? Like, if you think of it, to me, it's still mind-blowing, and I've seen it for ages, but it's incredible. So, if we take a look at how this applies to like common holograms, in this example, we've got like a table, right, with a 2D UI slate. So think of your mail application in a 2D form inside your 3D environment. A hologram which is far away, out of reach, and a few holograms right in front of you, like at arm's reach. So if I want to touch or interact with a hologram which is within arm's reach, I literally do that. Okay, here we have an example where there's a bounding box around, and you'll see lots of bounding boxes in the presentation. But you literally reach out and touch or grasp. If it's a far 3D hologram, you can use hand raise, just like you would with a VR controller. And that's really cool, like switching between the two just based on distance, and it just works. That's incredible, and that's one of the things that we are bringing into MRTK. And if I want to interact with the 2D slate, I interact with it as if it was a touchscreen, as if it was a phone. It's just here, I literally scroll up or down, poke, zoom in, do all my normal stuff that I would probably do on a touchscreen. So it's super, super instinctual. Here's another example about feedback and how a hologram has to provide feedback. Now, lots of people ask, like, so what about haptic feedback? Yeah, on a floating invisible device, you won't get haptic feedback, and we don't have gloves or any sort of ring or anything. So what we have is visuals and sound. 3D sound of HoloLens is just incredible. It's even better now. And visually, we need to provide feedback. So in this example, as my hand gets closer to, let's say that this is a hologram, as it gets closer to the screen, I should be able to see that the screen is aware that my finger is not too far. So it should show me what is interactable and what is not. So think of a flashlight on the tip of my finger. So as I get closer, I would see a ring of light. But as I get closer and closer and closer, that ring will start to become smaller and smaller until I eventually touch it. And that's when the hologram changes color or does some kind of highlight and audio cue saying, hey, you've touched, you've grasped, you've done something. And then as you move it back, it returns to its natural state, or it changes if it's a toggle, whatever. But it has to be super clear. Remember, also, depth perception of most people is super bad. So imagine aligning a hologram with a real hand. That depth perception is not perfect. So you have to help them out. Here's a beautiful example. This is concept art of what it would feel like when your hand is getting closer and closer to a set of buttons. And you can see this glass-like effect, which is actually the collider which you'll be pushing if you touch it. So without the hand near it, you would see just like the three icons, and as you get closer, you start seeing this glass-like physical forms that you can actually interact with. Hologram size matters a lot. And this will actually determine how a user interacts with them. So if you have a tiny hologram, say this pen, I would probably just grab it effortlessly and pick it up. Hologram, same thing, same exact thing. If you have something medium with a hologram, you would probably grab it with a bit of more force. You would probably grab it by handle if it had one and pick it up. And if it's a big object, you will try and reach out and really hold on to it. You might even use both hands. So if I have a hologram of a piece of machinery and someone tells you to move it, I would probably reach out and say, and do this. And everyone will do this. This is research. This is not just me making it up. Affordances. Has anyone heard the term affordances? To me, this was new. Like having a visual aid that represents a certain behavior on an object is really, really important. And we kept it super simple. The bounding box actually, the main goal of the bounding box is to be this representation that could encapsulate any weird form or shape in a universal way, right? So now if this cup was encapsulated by a bounding box, as I get closer, I would see the bounding box. And once I see the bounding box, I know what a bounding box does. I can grab it, move it, scale it, rotate it. And affordances actually tell me, oh, this corner actually lets me scale it up or scale it down. Or the affordance on the edge of the bounding box actually allows me to rotate something on an axis. So it's really important that when you use bounding boxes to make sure that you highlight the things that people can interact with. And MRTK should solve this, and it's coming. Here's a beautiful concept art of what a bounding box and an affordance is going to look like, and a nice fingertip mesh that you'll be able to customize. That's going to be cool. Physics. So yeah, it's super fun to play around with objects and move them, but it can become very frustrating when you want to move an object to a specific place, or you want to push something in a certain direction. To have real physics applied is out of the box. You know, with Unity, for example, you can just do it, but it can become very frustrating for the user. So you always should apply like certain constraints. So if I want to push it forward, make sure it pushes in that same vector constantly and not just wiggling around. Same with rotation. Try to restrict axes, make it easier for the user. And if you want them to have complete freedom with an object, let them grab them, rotate them, play around, let them go, and then it goes back to its original state. So what happens when you start combining these input methods? Like say, hands and voice. With my hand ray, I point to a far hologram and I say, make this twice as big. That's pretty magical, super powerful. Or I select a motorcycle, hologram of a motorcycle, and I say, make it this big. That's mind-blowing. Like, I just say, like, I want it this big, and it does it, and it will automatically scale it. You could do that now. Or eyes plus voice. I have a slate with Edge or a browser, and I just want to zoom in. I look at where I want to zoom in, and I say zoom in, and it zooms in to that point where I'm looking at. My gaze is my pivot point for the scaling, in and out. Now, if you add semantic labeling to all of this, move that window there, behind the table. That's nuts. Like, imagine saying that to a PC, because that's what you're doing. Like, you know, I want this right over there. And it can understand it. That's just incredible. Not moving forward. There we go. So now I want to go into why it's so difficult, the eye tracking side. So eye gaze is not the same as head gaze. Head gaze is very wobbly already. It's hard for someone to do like a video capture with HoloLens on their head. But you can be very stable. You can point your cursor on things super easily. Eye gaze is not a replacement to that. Right? Eye gaze acts in a very, very different way. And of course, don't apply a cursor to your eye gaze. Like, never do that. Imagine looking around with something like weird following your focus. That would be terrible, right? So, there we go. So, as I said before, yeah, combine eye tracking with other inputs. It's super important that eye tracking by itself can be useful, but for user intent, combine it with other forms of input, whether it's voice or gestures or poking. Subtle feedback. So yeah, imagine you're looking around and all these objects are holograms and they're all selectable. I can interact with all. But imagine I'm a really bad developer and I say like, I want all selectable objects to be highlighted when you gaze at them, when you eye gaze at them. So everything starts popping up and highlighting. You would drive the user nuts in a minute or in seconds. So when you target objects that are interactable, you have to be super, super subtle and elegant with audio cues or highlights or rims or whatever you want to do, but you have to be super, super careful of that. And of course, account for imprecisions. It's not easy to target small objects with your eyes. That's hard enough in real life. I went back. There we go. So, yeah, it's running. So these are examples of how instinctual interactions are going to form part of your applications. Grabbing objects, just making them feel natural, letting users play with holograms and inspect in this case. I love this one, the amount of details in just like 2 seconds. So someone reaches out, you can see a certain glow in the bounding box as they get closer, telling them that something is going to happen. They are interactable. And as they get even closer, the affordance, the rotation of affordance appears. You only show it then, not before. Once you select it, you start rotating, you see a change in color, and then it goes back to its normal state. Another nice one, with one hand and two hands. Again, affordances and rotation and near interaction, distance. All these details are going to be super, super important when you start designing for HoloLens 2. Far, with one hand. Imagine doing that. You're like Spider-Man. Just reach out with an interactable object, do this, and bring it close to you. You can actually do this with voice commands if you wanted to, of course. But that's how far interaction could work. And notice that person is not doing an air tap. It's literally grabbing it and bringing it back. It's supernatural. Two-handed manipulation. Same thing, rotation, scaling from a distance. So it has lots of things in common with, you know, VR controllers, right? But it's even more natural. No choosing the right button. Just grab it. So now I'm going to leave you with these images just to inspire you, just to help you understand how this is going to apply in real life, like in a few months from now. So imagine if like factory floor with someone doing checking a digital twin of a device right there and just disassembling it and taking a look at all the stats. Or someone on a desktop application, like this is a new kind of desktop application, like where you can actually see a control center and see stats and how the wind farm is going on and control it. In a shared environment also. We're not far from this. Next lighting tools are going to allow getting much closer to this. Medical applications. Being able to touch and dissect it all with your hands and not having to air tap. Or with voice commands. Again, teaching This is another shared experience. So this one is actually using the spatial anchor service from Azure, the mixed reality services, to collaborate on one single application, which might be controlled or not, it doesn't matter, but people interacting with HoloLens 2, an iPad, or an iOS or Android device, all in the same place. Imagine if you use remote rendering, you could see details like this or even more on a hologram. By the way, when Nick mentioned remote rendering, the demo that we saw, that I think he didn't go into details, we stuck our heads in an engine of a truck. And it was just mind-blowing. Like, millions of polygons, you would just get closer and closer and closer and see nuts and bolts and just absolutely everything. Like, with no limitation whatsoever. It's just incredible. And these last ones about how would you interact with holographic UI? Nice, beautiful fingertips interacting with just traditional 2D slates. Or a button that you're getting closer and closer, and the button reaches out to you, so you know you just have to press it. Look at that keyboard. That's just gorgeous. The same rules apply. Buttons reach out to you. So I bet you're all wondering, okay, so when can we get started? And Nick went through a part of this. But if you visit aka.ms/mr, you're going to see this little chart which shows a bit of our roadmap in terms of development and how and when we can start playing with all of this. So we're going to have porting guides from HoloToolkit to MRTK, from HoloLens 1 to HoloLens Generation 1 to HoloLens 2, tutorials and samples then. In April, we're going to have like new capabilities inside MRTK for HoloLens 2, design guidance also, and more information on Unreal. Of course, you can visit HoloLens.com, another source of truth. And I want to leave you with the last slide, which is actually a new thing that we're launching this Tuesday morning, which is the reality show. And it's a live stream where Nick, myself, and other people from the HoloLens team will be chatting and answering questions around HoloLens 2 and MR services. And are we talking about Kinect 2? Maybe? Yeah. And it's every 3 weeks. We'll be posting the URL on the Meetup page, so you can take a look at it. It will be recorded and on YouTube for you to watch later. But it's a great opportunity to ask questions and get in touch with engineers and designers and PMs from the HoloLens team. So it can be very, very high level and extremely deep at the same time. So if you have a super hard question, just go for it. So yeah, and now open to like questions.
If you have any questions, can you just raise your hand and I can just come to you with the mic?
Well, I'm definitely very excited. I've worked with the HoloLens for like about 2, almost 3 years, and I've worked in like enterprise, and like, right now I'm in another field. But since this is an enterprise device, it was really popular. So you would go in, you would talk to these like Fortune 500 clients, and one of the questions that they would often ask would be like, "Oh, well, we saw these people wearing scrubs, in the surgery room. So there are other people currently performing surgery with the HoloLens, or are there people constantly on the factory floor that are using the HoloLens every day?" And like, well, there was this case where they used it, this one time, but not on a consistent basis. And like I said, I'm not in the enterprise field anymore, but I think one of the reasons also that's so, I mean, even if you were to put it on the conference floor, is just kind of reliability. Sometimes you would put it down and, you would like go to sleep, or if you had it connected to a server, it would disconnect. And in terms of just like working with the device, like if I have a phone, I can put it down, I can come back and turn it on, and I can count on it just being turned on 99% of the time. VR is now at this point as well. If I pick up a headset, I can pick it up. It's going to be on basically like a monitor. Do you think the HoloLens is at this stage yet in terms of like phone-like confirmation reliability, or is it getting there?
I think it's so it's still kind of an enterprise-focused device. It's not necessarily like, oh yeah, we expect people to just have it lying around on the desk. Like it's going to be probably in like some rack along with a bunch of others being charged when it's not in use. So I don't know if we're quite at that point yet. I don't know if we necessarily need to be there quite yet. But I think like related to that, it's like a 3-hour battery life. So it lasts a while, but you're definitely going to be needing to charge it throughout the day.
Can I add also the fact of the flip up? Being able to do this is extremely important in like first line workers specifically. It kind of does what you're saying in a way, like you don't have to put it away. You just do this. It's not running. Back on, back in mixed reality mode. I think that we are moving towards that because everything that you said, that list of requirements or use cases, every single customer that I have met has asked for that. And as you see, HoloLens 2 is actually a product of feedback from our customers. So it is going towards that. I can't exactly say how far ahead we are in that road, but yes, we are going there. Yeah.
Can you talk about which gestures are actually going to be enabled out of the box in the MRTK, and what's the model for adding new gestures? If you wanted to do sign language recognition, for example, how do you actually enable that?
Very good question. So from my understanding, we are trying to go towards a physics-based model where we're not encouraging gestures. We are trying to make you interact with holograms. And that doesn't mean doing like weird shapes because people don't remember them. They had trouble with the air tap. So that's why we are not recommending gestures. Now, sorry?
So collision-based?
Collision-based, yes, and proximity, and you've got like voice commands. Gaze can always help you. There was one example of one of the medical demos done just last week where there were a couple of, for medical use cases, there was a surgeon in front of a table doing this gesture to sort of like swipe along slides or pictures. That's super risky. In that environment, in that controlled environment, it will work perfectly because it's meant for a surgeon who can't move his hands more than this. But put it in anywhere else, and that just doesn't work. Like, I already did this just now. So I would have swiped along different things. So doing gestures is extremely risky. So going for touching and doing what you would normally do is what we're trying to recommend.
Interacting with something at a distance, you envision sort of a fake hand at a distance, kind of
funny,
and moving stuff around. Is that the kind of model?
I saw prototypes trying that, and that doesn't work very well. That's why I laughed. But yeah, the hand ray. We know that hand rays work really well, just like in VR. I'm not sure if you've seen anything else, but. What you'd like to add?
Yeah, I've seen a whole bunch of stuff for far distance stuff, but I think, yeah, interacting at a distance is not necessarily an intuitive or natural thing. Like, I don't normally reach over there and grab those flowers from here. So there's going to be at least some level of gesture stuff going on there. And of course, you do have access to all those joints. So if you wanted to do some of that stuff, you could. I'm sure machine learning might be a great solution for doing something like the sign language stuff. That would be a really great thing to see. But
actually, just a quick question. A quick comment. We probably have time for about 4 or 5 more questions. So that you can actually network and actually talk to these guys individually. So this lady's next.
Awesome, really great presentation. Nicole Lazaro from Zio Design. And I was curious, a follow-on, in a sense, there's new user input that's available in AR, so gestures is one of them. In HoloLens 1, you really had 2 gestures, the pinch and the bloom. What is the vocabulary? What is the vocabulary on that? Because we didn't really quite hear that. There are 25 points, I believe, that you can track on the hand. To do sign language, we would also need to know arm boning. Is that tracked? And then what about eyes? The eye tracking stuff. But anyway, so gestures. How many do we have?
I think we still have Bloom, don't? No, we don't. We have like a. I that might actually still be in review as far as how we're accessing the start menu. But I think right now I've seen it as kind of like a squishing fingers sort of thing. So there might be a little bit there as far as operating system is concerned, but not a lot. We're keeping that still to a minimum.
So basically it's going to be buttons, and then I have some kind of collision, like we were saying, or maybe I have a pinch gesture to interact.
Once you do something like that, that'll bring up a menu that you then interact with through
So our UI is
physical
buttons and containers, rectilinear containers that I'm going to be moving the points of. If I want to pick up a jellyfish, the jellyfish has to be in a box.
It doesn't have to. We recommend certain ways to represent an interactable object, just so people understand that, and it can be consistent across different apps, just like any OS. But it doesn't have to.
And so you have eye gaze for intent, or my eye focus, so you could do foveated rendering, some fun stuff maybe. What about the eye itself? We do like emotion tracking. So I did the 4 keys to fun, and I actually built a model on how do you create emotion from interaction, and using microexpressions by Paul Ekman. Are we going to get, with eye tracking, are we going to be able to get some of the musculature around the eyes? Because I could decode that into some emotions, which would be great. Yeah, or is it just like where I'm looking?
It's a super interesting idea, but I don't know much about that, unfortunately. Sorry.
This gentleman first.
In your presentation, you had mentioned one of the use cases was in terms of virtual team collaboration. And I was curious, what were the actual interactions with the HoloLens that helped make that happen? So I'm thinking today in terms of like just straight video conferencing, was it simply that there was a model that you were interacting with, or was it purely person-to-person interaction that you were trying to enhance?
So when it comes to interacting with people on HoloLens, either remotely or in person, so the big advantage that the HoloLens has is that it has a very open sort of visor. You've got a good peripheral vision, so you can still like make eye contact with people that are actually here in person. So that's kind of a big deal for maintaining interaction in person. But then you also have the remote stuff as well. You can take somebody who's off in Berlin and bring them into the same room with you. So you can then collaborate with people who are co-located as well as remote. Yeah, I mean, when it comes to remote stuff, you could do all sorts of different things. Avatars, yeah, maybe you can take a Kinect and scan them or something like that. But.
Yeah, thank you. Yeah, how many HoloLens 2 users do you project by the end of 2019? Like in terms of purchases and stuff like that,
Yeah. If we had a number, I don't think we could share it, but it's probably more than the first one.
Cool. And then mostly enterprise, right? That's what you're
That's
saying?
our focus,
So
yeah.
very few consumers.
I don't think our pricing really reflects consumers. It's still it's a great device and it does a lot of really good things, but it's not something that you would see a consumer wearing. Like consumers just aren't going to wander around with a bulky headset like that. It's also only 3 hours of charge, so you wouldn't really want to be charging that in the middle of the day. Like it's way better than it used to be, and it's a really fantastic device. But I think it's still a little bit before we're going to see consumer use here.
Hi, thanks for the great presentation. Just a quick follow-up question to the hands tracking. What's the field of view of the sensor array? Like, can you reach out without looking with the sensor array? What is the field of view?
For the hand tracking?
For the hand tracking for the entire sensor array.
I believe the Kinect has a field of view of 120 degrees, and it's also pointed downwards a little bit from the visor. So I don't know exactly if we're using all of that for hand tracking, but that is the theoretical range, I would say.
couple of quick more questions. IPD, do you still need to measure that with the HoloLens 2? Do you still need to measure the IPD with the HoloLens 2?
It's automatic.
And
So
how about...
you can basically forget about it. Yeah.
Wonderful.
Yeah.
That's great. And outdoor use cases. I mean, I know that you're still using waveguide optics. How did you look at kind of solving that issue that we saw with HoloLens 1?
Maybe you can talk about light more than me.
Yeah, I don't know too much what our stance is on how well it works outdoors or not. I know the screen brightness, I think I saw 500 nits. I believe the Kinect also has an upper limit somewhere on it as far as how well the depth sensor works in bright outdoor situations. I don't remember that number off the top of my head. I'm not entirely sure, but it should be better than the first one. Yeah.
The main issues of outside is not just light. It's like tracking, of course. You need a decent environment. But light, I haven't seen it as an issue for most of the customers that we've talked with. And most of them, I wouldn't say most of them, the ones that I talked with, a big chunk of them were outside. Like,
you're looking at Trimble, right?
both actually, yeah. Like Trimble is a great example. Another one was like Airbus. Airbus has to be most of it outside.
Sorry to interrupt. Can you just repeat his question? This is Mike with him, and he asked about indoor and outdoor use cases.
Yeah, according, like, if the HoloLens 2 works well in outdoors or as well as in indoors. But yeah.
Yeah, so I had some questions about the spatial anchoring service. What sort of information is going back and forth? I imagine the API can be consumed by other devices you mentioned. Can you do things like anchor a piece of audio, example?
So the spatial anchor service uses the camera on your device. I don't know exactly like if it's sending the whole stream up or if it's a parsed stream. But as far as what you can attach to that anchor, that's entirely up to you. You can attach any sort of experience or data that you want to. It's going to be per application. Yeah.
What's important to say is that the anchor information has metadata, but the storage of any extra data is up to you.
So it's essentially like giving you a virtual space in the room that it's mapped, and then from there, you're saying this is an anchor here, an anchor there, and so forth as you drop objects, or...
Right, and all the extra information for you to understand, like to what application it belongs to, and all the inners and outs of IDs, like app IDs and all that, for you to be able to manage yourself, your application. Because it stores anchors. It doesn't, for now at least, it stores anchors. It doesn't share the application automatically.
So you don't, for instance, have an understanding of the point of view. You just have the orientation of what you've anchored. So if I've anchored this over here and I'm an iPhone over here, I'm looking at it one way. But if I'm over here, with the HoloLens, I'm seeing it from a different angle.
Yeah. The orientation of the anchor is persistent too. So if you leave an anchor facing a certain direction, everyone will see it facing that same direction. So, and one important thing to say is persistence. It's meant to be persistent.
Thank you.
Hi, does anybody else have any other questions? Yep.
Just a follow-up question on spatial anchors. You mentioned that it's using the camera data, and you didn't mention IMU. So is implied in that statement that you're only doing it based on RGB, or are you using sensor fusion or leveraging a platform sensor fusion like AirCore and AirKit?
I believe it does leverage positional information. I don't know the back-end tech behind that, though.
So it doesn't need, so as far as you know, it only needs the RGB data?
It probably does use some positional tracking like IMU and sensor fusion. I'm not entirely certain, but... All right, I think that's one brief last one, and
If I could take your mic, do you want to have a quick look?
No, I already
You
looked
good?
at it. Just went.
Sorry, who's the next one? Thank you. Thank you, Vanessa.
Specific question to the build. If you build for ARM, for like the Windows Store, if you build for ARM and for x86, it will still work for both HoloLens 1 and 2, is that correct? Assuming you're building with 2018.3, et cetera, and you haven't done anything that will...
I don't know too much about the packaging stuff. Like, you'll definitely need ARM for the new one. The old one is still x86, but I don't know how things work beyond that. Sorry.
Okay.
All right, thanks, guys. That's it for this evening. Feel free to hang out. There's still some pizza and a little bit of alcohol, so thanks for coming.
So yeah, as Nick and Dan just mentioned, there's plenty of alcohol back there, plenty of pizza back there. Help yourselves. Thank you, Nick. Thank you, Dan, for awesome presentations. This was obviously an overview, and we're going to get much more in depth as the meetups continue and the reality shows continue. Tuesday is the first realities show, so sign up to our meetup group, and you'll find out all the details of everything we're doing. And thank you very much for coming. We appreciate it, especially in this god-awful weather. Even though we need the rain, we need the drought to go, right? Thank you.
Got someone else infusing me. Say, is this when I gave or I gave up? It's like I know what to say, but something's getting in the way. This person that you so admire, now it's stuck in such a bad attire.
Oh my God.